Hello, everyone. Welcome to today's webinar, SingleStore Ecosystem, a primer on data ingestion. My name is Diogo, and I'll be your moderator. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in a listen-only mode. You may submit questions throughout the session using the Q&A function in the lower right corner of your console. We will answer everyone's questions after the presentation. After today's webinar, you will receive an email with a recording. If you wish to contact us, please email us at team@singlestore.com. So let me introduce our speaker today. Julie Price is the Senior Product Manager at SingleStore. Welcome, Julie. You now have the floor.
Thanks so much, Diogo, and hello, everybody. So thanks so much for joining us for the first in a series of talks about the SingleStore ecosystem. As Diego mentioned, I'm Julie Price. I'm a product manager here at SingleStore, and I focus on all of the integrations with SingleStore, from our native drivers and client libraries to integrations with open source community and third-party tools of all kinds. Well, today we're really going to focus on data integration. So we will start off focusing on the SingleStore ecosystem in general. And then we'll dive deeper into some of the specific ways that you can integrate your systems outside of SingleStore, whether it's pulling data from different systems, building applications, or integrating with tools like Apache Spark and Kafka, or third-party ETL, streaming, and CDC tools. All right, so let's get right into it. Now, some of you might be familiar already with SingleStore, but for those who aren't, it's a distributed relational database system, and it is highly optimized for data-intensive applications. So now you might be asking yourself, what exactly is a data-intensive application anyway? And the answer to that is really to understand the various different characteristics and dimensions that define the data intensity of an application. So does your application have really high volumes of data that you need to process to the tune of several terabytes or hundreds of terabytes? How quickly does the data need to be ingested? Are you looking at thousands of rows per second or millions of rows per second? And how active and rapidly changing is that data? Do you have really low latency query requirements? Are you serving web applications where you need to have single millisecond response time? And is your data model relatively complex, or is it kind of flat? And then finally, how many users are accessing the system at once? How many queries are being run at once? Are we talking about a handful, or looking at potentially tens of thousands of queries? So with traditional architectures, once an application starts to rank highly across 3 or more of these dimensions, that's when traditionally you end up starting to add additional solutions to your architecture. Your architecture might end up looking something like this, and I've actually managed architectures that have a lot of these characteristics in the past. It's really not uncommon to have MySQL or Postgres or Oracle as your transactional system. And then when you want to perform analytic queries, you don't want to load down that transactional system, so you bring in things like Hadoop or Teradata or Snowflake. Then if you have the needs to serve really low latency or high concurrency workloads, you start to bring in Redis and other solutions. And then if you think about different types of data processing or data, doing full text search, you might bring in Elastic. If you're doing other types of time series processing, you may bring in other solutions as well. So the list can go on and on and on. It's a very busy space. And I mentioned I've managed, maintained a lot of these types of systems before, and it gets really complex and incredibly time consuming. And so that's really where SingleStore comes in. SingleStore was built to eliminate a lot of that complexity. It's really built to provide you with a single scalable relational database for your unified data and optimized for data intensity. So those sound like a lot of great words. What does that really mean? So what do you expect from all of your kind of traditional relational databases built on modern architecture? You want ACID compliance, you want full ANSI SQL. SingleStore offers all of that. And it's built on a distributed cloud native architecture. It's got built-in high availability, the ability to scale online to match your workload, and the flexibility of the separation of storage and compute, which is really the way that things are moving everywhere in the marketplace today. And SingleStore is also multi-model database, so it eliminates a lot of that complexity in a variety of different ways. So one of the key differentiators of SingleStore is this concept of universal storage. It's a totally unique single table that can handle both transactional and analytic workloads with scale and speed. So it takes away all of the data movement that you would need to do between your transactional and analytic systems, gives you the ability to actually process and analyze your transactional data in real time. It also gives you additional support, not universal storage, but SingleStore in general gives you additional support, not just for relational, but for things like document and key value data, time series and geospatial, and full text and streaming all through a single API. So it really was built with this idea of simplifying that architecture in mind so that you no longer have to look at that eye chart and think about how to integrate all of these systems and move all of the data around to keep it in sync and accurate. Now, finally, SingleStore is truly optimized for data intensity. We've built in a whole series of technical innovations, both in the distributed query execution engine and in the patented storage architecture, to provide the absolute fastest ingest and the fastest query speeds and support for exceptionally high concurrency. So if you think about putting that all together, SingleStore can ingest millions of events per second on highly active data with support for ACID transactions while simultaneously supporting things like ad hoc SQL queries, BI tools, applications, machine learning models, various types of queries like that, all on trillions of rows of data. So now, if SingleStore is the heart of your data-intensive application, and you don't need to bring in all of those other databases, you still need to have ways for the data to flow in and out of the system. And so SingleStore has a really large ecosystem of tools for ingesting data, building applications, and performing analytics. SingleStore makes it even easier to integrate because it's MySQL Wire Protocol compatible. So in addition to any of the native connectors that we offer or that our partners offer within the ecosystem, you can also connect with any tool that has MySQL interoperability. Additionally, SingleStore can run anywhere on any cloud platform on premises, so it's really your choice for how and where you want to deploy the system. But we are here today to talk about data ingest and integration, and so we're going to focus on this upper left-hand corner of this diagram for this session. So if you think about data coming from lots of different places and many different formats, you've got data coming in from social media platforms, different types of devices, your business systems, third-party data sets that you want to integrate with. SingleStore has to be able to ingest that data essentially from anywhere, in any format, and at any speed. So in the sense of your business data or third-party data providers generating structured data that needs to be loaded either in batch or real time, we've got capabilities for just doing native bulk loading. So load data from file systems, from various different cloud storage providers. So you can pull that data into SingleStore. We've got a native capability that's really amazing called pipelines for real-time ingest and transformation. We're going to dig into that a lot more deeply coming up. And we've got integrations with lots of third-party ETL tools like Informatica, change data capture tools like HBR, and continuous data delivery tools like StreamSets and things similar to that. And then when you think about those sort of systems of engagement, social media platforms, IoT, mobile devices that generate semi-structured and unstructured data, this is where we need to start thinking about integrating with the likes of Kafka and Spark for doing some pre-processing of that data and delivering that data as it essentially is being streamed in from those various different systems. And so we've got native integrations with those two systems that we're going to talk about in detail actually right now. So when we talk about the data ecosystem in general, you really have to consider the Apache ecosystem, specifically Kafka and Spark. I mean, there's loads of other tools and frameworks in the Apache ecosystem, but specifically Kafka and Spark are really widely adopted for their scalability, their functionality, and their performance. and they are really excellent complements to SingleStore. So in order to take full advantage of the computational power of Spark, all of the different libraries that exist, and the low latency and exactly one semantic data delivery of Kafka, alongside the fast ingest, low latency, and high concurrency of SingleStore, we have built out native connectors for both of them. And so we'll dig in to some of the details of them, of both of them, and talk about how some customers are using them. So first, we'll address Spark. For those who've been working in the Spark area or working with Spark technology, you know that it's excellent at iterative computation, has tons of libraries for all sorts of statistical analysis, graph computations, machine learning. But Spark SQL is not true ANSI SQL, and it really isn't nearly as fast or efficient at query processing as SingleStore, and certainly not as simple to work with as SingleStore. So we had the opportunity to essentially bring these two systems together and build a bridge or a connector that can look at solving some of the issues that you might see with Spark and other data platforms, like some of the slower query response times and slower data loads that you often get. This is done by implementing the Spark connector as a native Spark SQL plugin. So it supports Spark's data source API that's commonly used with Spark SQL models, so you can leverage your existing models in place without making major changes to them. And one of the really phenomenal features about it is this push down query processing capability. So essentially it's going to push down the processing into SingleStore in true SQL. So you can take advantage of all of the optimizations of SingleStore, the speed, the scale, the parallelization, and it results in massive performance improvements over processing the same queries directly in Spark. And since Spark and SingleStore are both distributed, the connector was built to be able to directly read distributed data in parallel. So now, instead of essentially reading things sequentially, we can access the data across a distributed system, and it results in order of magnitude performance boosts in loading things like data frames in the Spark framework. And then finally, the connector leverages SingleStore load data command. So actually pushing data back down to SingleStore is optimized because we can push compressed data down. And all of this adds up not only to the fastest data platform for integrating data and moving data, but also for running analytics and machine learning. So you're getting a lot of capabilities through this single integration. And if you think about how you can use the connector and bring Spark and SingleStore together, you can use it to build brand new, smart, data-intensive applications. So instead of that old story where you're moving data around between lots of applications, you now can still take both streaming and batch data sources, along with sources like S3 or other cloud storage in Kafka, and build a unified AI-driven application, which is what Spark is used for quite a bit. And some really big companies that you're probably quite familiar with, like Uber and Hulu, are doing exactly this. Well, that's one design pattern. Another design pattern is augmenting existing applications. So if you have other data infrastructure that's out there, like Snowflake or Google BigQuery, Databricks, and potentially you've got some scenarios where you need to have better performance than they can provide, essentially you can leverage the Spark connector with SingleStore to stream the data into SingleStore and augment your existing analytic infrastructure with these accelerated analytic applications where needed, but still continue to leverage the investments that you've made in those other solutions for the broader set of data that maybe doesn't need the performance boost that SingleStore provides. So to wrap things up with Spark, we'll talk about some of the key features of the Spark connector. So first of all, you are getting a true Spark data source compatible with JDBC reader and writer API. It is implemented as a native Spark SQL plugin, and it has this really robust SQL pushdown support, which includes partial pushdown. And this is a part of, kind of the differentiating factor of this connector is that when you have some type of Spark syntax that maybe can't all be pushed down, but some elements of it can, there's intelligence in the connector that says, let's take this bit of processing, push it down to SingleStore so that we can take advantage of all the optimizations there, and any bit of Spark processing that can't be done in SingleStore can be done in Spark, and ultimately the results brought together in the end. And so, we talked about the loading data, the loading compressed data, so getting a lot of optimizations there. And finally, since we own and operate this connector, we can take advantage of all the latest and greatest features of every SingleStore release. And one example is that SingleStore 7.5 now has the separation of storage and compute. So the Spark connector has the ability to take advantage of the SingleStore compute layer directly. And we have the ability to add in additional performance optimization using other key features of 7.5, like enabling parallel read as well. So now let's move on to Kafka. Data-intensive applications, I know I keep saying this word, but it's really critical because this is what SingleStore really excels at, are these data-intensive applications which have, scale high on 3 or more of those dimensions that we discussed before. And in this case, a lot of data-intensive applications require answers in real time across huge quantities of rapidly changing data. We know SingleStore can do that. We can manage those scenarios without issue. It turns out that Kafka is also perfect for this type of data-intensive application. So Kafka is incredibly efficient at moving data between systems. It can handle real-time data delivery to SingleStore at the scale of millions of rows per second. Both systems have exactly one semantic, so you know the data will be delivered accurately. Both systems are distributed, which enables optimized parallel ingest of the data in the SingleStore and provides high availability and fault tolerance to both of those systems. And together, the systems really are developer friendly. Kafka has the pub/sub model. It's compatible with lots of common programming languages, and SingleStore is ANSI SQL. So common kind of commodity skills that lots of developers will know and understand. So it's really easy to adopt Kafka and SingleStore together. So Kafka and SingleStore have 2 different methods of integrating together. I will talk about both of them a little bit more coming up, but the TLDR is that you can either pull Kafka natively with SingleStore pipelines. So you'll, on a regular interval, use SingleStore pipelines to just pull the topics and subscribe to them. We'll talk about SingleStore pipelines a lot more coming up. Or you can leverage the native Kafka connector that we've written to write the data directly into SingleStore. So this is more of a push methodology to push the data from the Kafka topic into SingleStore. So when you bring Kafka and SingleStore together, you have the ability to build out modern real-time data architectures for those data-intensive applications. In this case, using Kafka kind of as the primary data delivery method or the hub that's going to bring everything together. So in this scenario, you might have various different systems of record that are built in other systems. You've got your systems of engagement, those social media platforms, your devices, and other things like that. And essentially, those systems can be pushing data out to topics as changes are happening. SingleStore can ultimately be listening to those specific topics to load the data into SingleStore tables. Now SingleStore can process the data in real time. It can be immediately analyzed by operational dashboards, by reports, by machine learning apps, or it could be used for pre-processing of the data. Now you could store the data long-term for reporting and trend analysis, use that history for building and operationalizing models as well. And you might notice that there is a bidirectional arrow between SingleStore and Kafka. And that's because as SingleStore processes the data, you can also push it back to another system. You could push it back to Kafka. So essentially publish that data back to a Kafka topic, and then other systems can consume that data, like smart applications that are making predictions or doing recommendations. So it is, a bi-directional integration that you get between Kafka and SingleStore to produce these really powerful real-time data architectures. So you can also take it another step further to take the prior architecture and turn it into something like a digital integration hub, where SingleStore can act as a reflection of a transactional database. In real time, you can allow microservices then to use that data to publish it to systems of engagement. So think about a banking system. It's got millions of accounts, and you want to create a web or mobile application where a user can log in, check account balances, see all of their transactions. You don't want to expose the transactional system to all of those microservices. You can do that essentially by moving that data with Kafka in real time into SingleStore, and then allowing those microservices to directly access the data that's sitting in SingleStore instead. So you may be wondering how all of this is made possible. And again, both systems are fully distributed. We'll take a second to kind of look at the SingleStore architecture and the Kafka architecture to see how they kind of relate to each other. SingleStore architecture has an aggregator and leaf architecture. The aggregator nodes are responsible for taking and resolving any type of requests, queries, data load commands that come into the system, and pushing them out to be processed by the various different nodes. Also responsible for storing all of the metadata of the system, so it knows where all of the data lives, stored across the distributed nodes. And as you might have guessed, leaf nodes are where the data gets stored across partitions within each leaf. So the aggregator nodes understand which leaf contains which data, which partition within which leaf contains which data, ultimately. And within Kafka, you have the ability to essentially partition your Kafka cluster and topics, and ideally to achieve the maximum level of parallelization and ultimately the maximum optimal performance. You would have your Kafka and SingleStore clusters have the same number of partitions. So when the data starts to come through, SingleStore can query the Kafka metadata, establish the appropriate mapping from partition to partition, and then just move that data directly where it needs to go. So it creates this really extreme level of parallelization and enables incredible performance, which we'll discuss even more coming up. So talking about Kafka really is a natural segue into SingleStore pipelines. SingleStore pipelines is a native database construct. It enables you to ingest and transform data from Kafka, HDFS, various different cloud storage buckets in AWS or GCP or Azure, and it leverages all of the processing resources of your SingleStore cluster. Pipelines have support for common data formats like Avro, JSON, CSV, and Parquet, and it provides you with the transactional consistency and exactly one semantics that you need to know that as your data is moving from wherever it's being produced, wherever it's coming from, into SingleStore, that you're going to get the data as it should be. So it's a really powerful built-in capability that enables real-time, scalable ingest of massive volumes of data without having to actually bring in other systems. But it provides you the capability of integrating with lots of other types of systems by producing the data either through Kafka or loading it into the various different file systems to be essentially sucked into SingleStore directly. Now, something that's really powerful about SingleStore is that it's not just used for ingesting or extracting the data from the data sources, but you can also transform the data as part of the pipeline before it gets loaded into SingleStore. So transforms can essentially be written in any language that you can process JSON, Avro, and CSV data. So you can write Python transforms, Java transforms. It doesn't really matter, but essentially you can use the transforms for performing all different types of computations, aggregations, feature engineering, even execute scoring models or call out to APIs. The only limitation is that the Linux distribution must have all the required dependencies in order to execute the transform. Once they're there, the sky is pretty much the limit. You can do whatever you want with those transforms. In addition to transforms, you have the ability to use SingleStore stored procedures as well to mutate or modify the data. And so we'll look at kind of the full anatomy of a single store pipeline sequence, how it works and integrates with Kafka and with other data solutions end to end. So how does pipelines work is that we essentially will pull the data source for changes on a regular basis. It'll pull the data into memory where then the transforms can be applied. So remember, transforms can be written in Java, Python, Go. Pick your language, install the dependencies, and you're good to go. And from there, data can either be converted into table columns and directly inserted into tables, or it can be pre-processed by a stored procedure before being written and committed to the database. And the really powerful part of pipelines is the ability to essentially write the data back out to a Kafka topic. So as you're pulling the data in, you do the transformations that you need to do. Maybe you run some scoring against that data and you want to write the results back out to a Kafka topic so that it can be consumed by other applications. It can all be done in real time with this pipeline sequence. And then the results of the data of the entire transformation or pipeline can be distributed, it can be ingested into SingleStore using a distributed ingest stream. So it's highly parallelized, so you get the data in as quickly as possible. So this really enables you to process millions of rows per second with pipelines, provided that you can get the data that quickly. And that's exactly what one of our customers, Akamai, has done with Kafka integration and SingleStore pipelines together. So pipelines are really powerful, but they're also quite simple. You can see the script here. It's just a couple of lines essentially that build a pipeline. This is an example pipeline where we're just creating or replacing the pipeline. We're naming it. We're saying we're loading the data from Kafka, identifying where the Kafka, how to connect to the Kafka topic, what the topic name is. We're applying transformation in the form of a Python application, loading data directly into a table called live predictions, and processing that data through a stored procedure as well. And then we just start the pipeline and we're ready to go. Now, Akamai did something very similar to this, and they were able to do essentially 10 million upserts per second using Kafka and SingleStore pipelines together. So upserts, we're not just talking about inserting data to the table, but actually highly active data, which is hugely differentiating because it's really difficult to do that in other types of systems, along with enabling doing analytic type of queries against that data, ultimately enabling daily billing for its content delivery network and security services. So it opened up a whole new methodology for billing, ultimately to increase revenue. Now, leveraging our native integrations with other distributed systems, specifically with pipelines, will generally be the most performant way of getting data into SingleStore, but there are lots of scenarios where other third-party integrations make sense. Now, it's definitely a high priority for SingleStore to offer integrations with the tools that you use most, specifically for building out those data-intensive applications. So we've got a lot of integrations that exist here in order for you to stream data in, to do bulk loading of data, batch processing of data. So we're integrating with common ETL tools like Talend and Informatica Power Center, Informatica Cloud. We are supported target databases for CDC, change data capture, and continuous data delivery tools like Blitz and StreamSets and others shown here. We have integrations with the major cloud provider tools like AWS Glue, Azure Data Factory, and Google Dataflow. And it definitely bears repeating that the MySQL compatibility means that there are hundreds, if not thousands, of additional integrations that are available to you through that compatibility. And I also wanted to mention, I know I kind of quickly said that you can leverage the SingleStore Kafka connector, either with kind of standard open source Apache Kafka or through the Confluent Hub. And I just wanted to kind of drill in on that a little bit because it's really great having this connector available to Confluent Kafka. It's super easy to get started with. Everything essentially just works. And it turns out it's 5 times faster than the JDBC connector that customers were essentially previously using before. And another great addition to the SingleStore ecosystem that enables integration with lots of third-party providers and data integration vendors is the newly announced native SingleStore ODBC driver that you can use for building out those data-intensive applications. So we've just announced this into general availability within the last month. Really excited about having this capability now. So as we move forward, we'll be looking at having all third-party integrations be based on the native driver. That'll give us a lot more control over performance, functionality, and adding various different features. The driver is compatible with Windows, Linux, and macOS. It's open source for extensibility, so you can go out to the GitHub repository, either download the latest releases, or you can actually download the code set and extend it the way that you see fit. And use the driver to connect SingleStore to all of your favorite data integration tools, as well as things like building .NET applications or Python applications. Any type of data-intensive ODBC-based application that you're looking to integrate with or build, you can use our ODBC driver to do that. So, there's all of that information for you. So what's next? Now, you've learned more about SingleStore and its large ecosystem of integrations, some of it through the MySQL interoperability, others built natively on SingleStore technologies. You've heard about the deep integrations between distributed systems like SingleStore and Spark and Kafka, and how they can really provide the foundation for powerful modern data applications. And finally, you've learned about some of the key integrations between SingleStore and third-party data integration tools, as well as the opportunity to leverage our own ODBC driver for even further integrations. Now, if you're ready for more information, you can follow these links to the documentation specific to our data integration connectors, as well as the GitHub repositories for the Spark and Kafka connectors, and the SingleStore ODBC driver. And if you're looking for other ways to learn, when you're ready, you can give SingleStore a try by spinning up an instance in minutes with $500 in free credits for the SingleStore managed service. And there's lots of great resources that are listed here, our docs, our forums, incredible content out on YouTube, and lots of great training content. But I specifically, and a little bit selfishly, since I am responsible for integrations, I want to draw your attention to SingleStore Forum. So if you have any questions about connectors or requests for new native connectors, because we're always looking to expand our ecosystem, the forum is a place for you to post them. You can tag me in the posts. I'm J Price, so at J Price, and I will see them. And just do that so that we can continue to make our ecosystem stronger and better for building out those data-intensive applications. So thank you so much for your time today. I'm really excited to connect with you on the forums and see you at our next ecosystem webinar. And with that, I think we can wrap up the presentation portion of the webinar.
Thank you, Julie, for this awesome presentation. As a reminder, the Q&A function is in the lower right corner of the GoToWebinar console. So if you have any questions, you can drop a message there and we will answer using this last few minutes. I already have some questions here, Julie, so I'm gonna see those to you. What Spark versions are supported by the SingleStore Spark connector?
Good question, thanks, Diogo. So we currently support Spark 2.4, 2.3, and 3.0. So there's specific Spark connectors with all the right dependencies for those various different Spark versions.
Awesome. The second question is, how can I decide between the different options for integrating with Kafka?
Also a really great question. So we talked about how the pipelines integration is a pull type of integration and how the Kafka connector is a push type of integration. Really one of the key things to think about, is that pipelines is going to be the most efficient way to get data in parallel along with your Kafka cluster. So if it's possible and there are no kind of network configuration issues that interfere with your ability to use pipelines to do that, that would be your first choice. but also lots of folks are already using Apache Kafka to using Apache Kafka in the Confluent space, or using Kafka to create those topics and collect that data. And so in the case where either you have issues with the pulling from, so connecting to your Kafka environment to pull the data, it's often easier to open things up to push the data out. And so that might be a scenario where you download and leverage our Kafka connector on your own, or if you're working within the Confluent space, then it's just very quick and easy to get started with that connector.
Third question is, why would I use the SingleStore ODBC driver instead of MySQL?
Also a good question. So, we've had this MySQL wire protocol compatibility for a long time, and it's opened up a lot of various different integrations, and it's really been good for getting started. But by having our own driver and by leveraging the SingleStore driver, again, we have complete control over performance optimization, over adding new features and functionality. So we've got some great new features in 7.5 that can optimize the performance of working with distributed systems. And we can start to integrate all of that functionality into our own driver, where we couldn't do that when relying on the MySQL driver. So we'll continue to have the MySQL compatibility, especially for integrating with a really wide set of tools. But going forward, as we continue to expand our ecosystem, we will depend more heavily on our own driver to make sure that we can give you the best possible experience.
Thank you. I want to thank Julie for the presentation. Thank you all for attending the webinar today. We will send you a follow-up email with today's recording and a link to our managed service free trial. We are offering each user $500 in credit, so you can start a full workload today. Lastly, check out our other virtual events at singlestore.com/events. Thank you for joining us and have a great rest of the day.
Thank you.